Howdy, welcome back to Advent of Code 2022. This is me, John Eisen. I'm going to be solving day 5 here. I did do day 3 and day 4, but the videos for both of those got messed up in different ways, so I wasn't able to post them, but they're available on my GitHub. So yeah, let's just dive into day 5. Let's get started. The expedition can depart as soon as the final supplies have been unloaded from the ships. Supplies are stored in stacks of marked crates, but because the needed supplies are buried under many other crates, the crates need to be rearranged. Okay, the ship has a giant cargo crane capable of moving crates between stacks. To ensure none of the crates get crushed or fall over, the crane operator will rearrange them in a series of carefully planned steps. After each of the crates are rearranged, the desired crates will be on the top of each stack. Okay, stack rearranging. The elves don't want to interrupt the crane operator during this delicate procedure, but they forget to ask her which crate will end up where, and they want to be ready to unload them as soon as possible so they can embark. They do, however, have a drawing of the starting stacks of the crates and the rearrangement procedure, our puzzle input. For example, we have this 3 different stacks here with crates with letters, and then we have move 1 to 2, 1 from 2 to 1. So I guess that means move 1 crate from stack 2 to stack 1. So then in this case would be move D to the top here, and then move 3 from 1 to 3. Position 3. Move position 3 from 1 to, move 3, a count of 3. That would move D and Z on top of P. Okay. In this example, there are 3 stacks of crates. Stack 1's contained Z is the bottom. Then the rearrangement procedure is given. Crate is a quantity of crates is moved from one stack to a different stack. So yeah, in this case we move 1 from 2 to 1, putting 3 on 1. Then we move 3 from 1 to 3, so 1 is empty. Then we move 2 from 2 to 1. That would move the bottom 2, C and M, to 1. And then we move 1 from 1 to 2. That would move C and then M, and then move M back, right? They get reversed. Let's just double check, right? So when you move a quantity of crate, they reverse them, right? So when they move D and Z to 3, they become Z and D, right? And then when they move CM to 1, they become MC. And then when you move 1, it becomes M. Okay, cool. The elves need to know which crate will end up on the top of each stack. In this example, the crates are C, M, Z. And so you should combine these together to give the elves message CMZ. All right, cool. So let's first copy our example. This is a very much more complex input than we've had before. So we're going to have to do some good, misspelled input. Let's get the puzzle input. All right, and our full problem has 9 stacks. Okay. So there we go. Let's close the rest of these tabs. Close tabs to the right. Nice. All right, and then let's go back to day 5. Cool. All right, so our input, let's start with just parsing our input. The first thing is we're going to want to know, we're going to separate our input into stacks and rearrangement or procedure. So we'll stacks and procedure. So that's a list of instructions, and the stacks are a list of stack. A stack is just a list of boxes, or right? What are we calling these things? Cargos, crates, crate, and a crate is a string, and an instruction is a tuple of, actually let's use a data class here, data class instruction, and we have a quantity int from stack int to stack int, and these ints are indices in the stack list. So there we go. That should take care of everything. So now we need to do the parsing. So in order to parse the, let's do the let's parse the easy one first, so which is the procedure. So we're gonna do stacks procedures equals raw dot split on double new line, and then the procedures is pretty easy. Procedure. So let's do def parse procedure line. So taking in a line, returning an instruction. We'll call this instruction, and we will return. So first we could do a regex here, but I find it's just a little bit easier to pull out things from using split, because I don't like importing the Python regex stack. So line.split from move to equals, and then our quantity equals move.split on space colon with the index of 1 cast to an int. So that should grab this move 1 and move 3. And then we do the from stack to stack, and these will just get ints. We're gonna do, well, we'll map int onto int of x for x in 2.split on space 2 space. So what this is gonna do is, actually we can just get rid of this and do it later. It's probably harder to understand this way. So we'll just get rid of the int castings here, but move.split index to 1 will split on this space here. So we only have this text, and then we split on the space to get this integer, and then with only this text we split on space to space here, and we get both of those, and then we return instruction of quantity equals int quantity from stack equals int from stack to stack equals int to stack. All right, and that should return our instruction properly. Next thing we want to do is define our parse stacks. Now this is a little bit more complicated, so we're going to get the whole raw input for the stacks. The first thing we want to do is parse we're going to do this zip procedure where we transpose a matrix, because essentially what this is a matrix, right? I suppose what we need to do is first identify how many columns there are. We could just know there's 3 columns, or we could figure it out by using our by using the last line. So we could just do columns equals raw -1 dot split on space, and then we just see how many of those there are. So in this example there are 2 double spaces, which would make that split have 3 items. And so we can just get the length of that list. So that's nice. So we can just use this as a hack. All right. So that'll give us the number of columns. And then for each column, we want to take 3 characters, which are either going to be this square brace letter square brace, or they're going to be empty. So we want to do and each stack is let's define that each stack is stored bottom up. So in our list of crate here, this is stored bottom is index 0, top is index len stack. All right, so that definition helps us later. So let's start by reading all of these values from the bottom up. So And let's just make it easy. Instead of writing it functionally, we can write it imperatively. So stacks is going to equal an empty array for I in range columns. So that's a nice little thing. So now we've initialized our stacks, and we're going to push crates onto them. So for row in raw colon -2 colon 0 colon -1. So this should index the array starting at the second to last element, meaning the lowest row, and then going up. And we can just double check this real quick by Python raw equals 1 A B C D E. We can do raw colon -2 colon -1. And what this gives us is, you guys probably can't see that, but I'll just blow it up. Whoa. Here. So this gives us DCBA. So that is what we want. We want to start at the second to last element and roll backwards. And so that is the correct indexing strategy to do that. So nice. So for row, and this will just give us each row, because raw is, we need lines equals raw dot split lines, and both of these should index lines. I was assuming I was indexing lines, but I realized I was just indexing a string, which is not what we want. Okay, all right. For each row, we need to go through. So for I in range columns, so I is our stack. So for stack I, we are going to grab 3 characters. So the next 3 characters will be, so there are 4 characters in between each to the beginning of each stack. So prefix equals stack I times 4. So for stack I is 0, we start at 0. For 1, we start at 4. So 1, 2, 3. So 0, 1, 2, 3, and then this character would be 4. So that's cool. So then the crate equals row of prefix colon prefix plus 3 to get the next 3 characters. And if crate starts with a brace and crate ends with a brace, then we do stacks stack I dot plus equals, so a nice little append, crate 1, which will get the crate out of there, out of that 3 character string, and otherwise we skip it. This should do it right, and then we want to return our stacks. Okay, and then parse input here. So we're going to do, the procedure is going to be a list, so we do parse instruction for line online for line in procedures dot split lines, and for stacks we do parse stacks on stacks. Okay, and that should give us the input. Argument missing for parse instruction for procedure. Oh, comma. Yep, okay. Missed the comma here. Oh, we didn't spell that right. Okay, cool. And then let's just print our input since it's so complicated. And then let's test it on the example. So our input has ZND in the first stack, MC, and P. So let's just double check it against what we have. So we want to store the stacks bottom up, so we go ZN, but apparently we're grabbing D first. Because it's trimming. We want to not trim. In this case, we're going to do an R strip. So that strip is actually trimming the first 4 characters from the input. But let's change this to a right strip, so it only strips the last new line, but not these first 4 characters. And save and try it again. So now we have stacks ZN, MCD, and P. That's well done. And then our instructions are quantity 1 from 2 to 1, quantity 3 from 1 to 3. Yep, okay, so everything's looking good with our instructions. So we did well. That was our first challenge. Now we just have to execute the instructions. So def execute instruction, and this takes a stacks of list of stack, a instruction, and it returns a list of stacks. So we can modify the stack, which is fine, or we can totally return the, we can modify, or we can just like create a new immutable stack. Doesn't really matter here since we're not reusing the input. So in this case, we'll just modify stacks because that's easier in Python, but ideally you would write this immutably and you'd return a new set of stacks, but it's a little bit easier here to just modify the current set of stack. So the instruction moves a quantity. So for quantity, well, we want to do for crate I in range instruction dot quantity. So this will we'll do this incrementally because we have to move like the stacks and reverse it. Actually, it's probably better to not do this, to do it all at once. We'll just do this in one step. That'll reduce our O of n, or our big O notation, for how long this will take, which could be a problem if there's a lot of instructions in our input. So we want to move 1 from 2 to 1. So we go stack of 2 instruction dot to stack equals stack from stack. Well, let's first get the thing we're going to move. Stack from stack of its last, so negative instruction dot quantity colon. So crates moving. So this will give us the crates that are actually moving, and it starts by going backwards on the list, which is the top crates, right? And then we want to reverse it by adding it to stack instruction dot to stack. I'm gonna make this smaller, so this is easier to read. So the to stack is going to have them added on the end, but in reverse order. So plus equals crates moving, and reversing is easy. You just do colon -1 with the Python indexing. So it's nice, stacks. And then we got to make sure we remove them from the from stack. So stacks inst.from stack equals stacks inst.from stack colon 0, or just colon to negative inst.quantity. Okay, so what this gets is it basically cuts the list off at that 1 from the end or 3 from the end or whatever. And that's nice. And then here we've reversed it. So this should do it, and then we can just return stacks. Actually, let's I really want to do it immutably, so I'm going to do stacks inst.toStack plus, and we're just gonna not modify the old list. So we're gonna do a shallow copy with new stacks, and then we're going to say new stacks from stack equals this, and new stacks here, and stacks.toStack plus creates moving. All right, so now we can return new stacks. So now we haven't modified anything, and so everything's nice and immutable. So we won't have any problems if we reuse the list and it's changed underneath us. All right, so now all we have to do is execute all the instructions. So for instruction in input.instruction, we want to do stack equals execute instruction stacks instruction, and stacks equals input.stacks, and procedure here is the name of this list, not instruction, and then we return the string. In this case, our inputs are returning strings, and we should return the top of each stack, so that's the last element in each stack. So we do a little join stack -1 for stack in stacks. Are we guaranteed to have something in every stack? Probably. We'll just say if len stack, just to skip something if there's nothing in that stack. All right, let's try it on the example. I mean, it's kind of a complicated problem, so we probably got something wrong. List index out of range on new stacks. We're probably gonna have to debug here. I don't understand. So oh, right, because these are 1 indexed and we have 0 indexed things. So what I'm gonna do here is I'm just gonna change our indexing strategy from 1 indexed to 0 indexed. And that way we don't have to worry about, oops. That way we don't have to worry about every time we use these indexes, like changing from 1 index. We're just gonna, when we read them in, change them to 0 indexed. CMZ, that's correct. Cool. Well, let's see if it runs on the input. Okay, it does. And remember, we had 9, and that is 9. Okay. Well, probably worth trying. Hey, we got it right. Nice job. All right, you guys ready for part 2? As you watch the crane operator expertly rearrange the crates, you notice the process isn't following your prediction. Some mud was covering the writing on the side of the crane, and you quickly wipe it away. The crane isn't a crate mover 9000, it's a 9001. 9001 is notable for many new and exciting features: air conditioning, leather seats, extra cup holder, the ability to pick up and move multiple crates at once. So in this case, our instruction, when we move 3 crates, we're not going to reverse them. We're going to keep them in the same order. I believe that's the difference. They begin in the same order. Moving a single crate, it's the same as before. However, the action moving 3 crates means those crates stay in the same order, resulting in this new configuration. And then, all right, so that's a very easy change. So we do, we're just gonna change our reverse equals true here. And we're just going to add a parameter of this function, and we're going to do if reverse, and then if reverse crates moving equals crates moving. Now I don't like to, if we were just doing this nice and fast, we wouldn't add a parameter here. We would just change everything, and then but I like to have everything work all the time. And so what we're going to do is have this nice part 2, and we're just going to pass reverse equals false to the exact same function, and everything should be good. And except that we need to return a string here. Nice. All right. So now we should be ready to go. We want MCD with our example. It's correct. With our input, we get this. And nice. We did it. So this was a really fun problem. Very complex input we had to parse, and we had to follow a set of instructions, which means the actual writing of the code wasn't too bad, but you had to be really careful to make sure you did exactly what they suggested. And part 2 was quite easy. We just noticed the exact thing we had to change, and we went and changed it, and we kept everything working, so our part 1 still worked, which I really enjoy. We got to use data classes in a nice way, and we got to check that our input was right. So I'll put this up on GitHub, and I'll see you guys next time. Let's like and subscribe, and yeah, see ya.